here today. I really appreciate it. And today I'm going to talk about corrosion in fire sprinkler systems. It is a problem across the entire world, even in the U.S. as well as Brazil. That should work. So the biggest concern that we have with corrosion in fire sprinkler systems is that it will actually cause a failure of the fire sprinkler system. Fire sprinkler systems are very effective at saving people's lives as long as they're properly maintained and inspected, as we've been talking about here today. As you can see from these photos that I have available, if you open up a sprinkler system and you see things like this, like the picture on the left, 50% blockage due to corrosion, or a picture on the right where there's enough corrosion in the sprinkler head that it wouldn't activate, the sprinkler systems aren't going to be doing anything useful for that building. One of the main problems that corrosion causes outside of a life safety hazard is it costs building owners money. Sprinkler systems are usually full of water, and they're usually protecting some sort of asset. As soon as a pinhole leak occurs, such as that you see in fire sprinkler systems, and water comes out, it can damage both property, it can hurt production of whatever they're making, and temporary shutdowns of whatever building that is. These are usually things that drive people to corrosion protection, to slow down these occurrences, especially in the United States. So I always ask this question, and I get a wide variety of answers, but what is the life expectancy of a fire sprinkler system? I get anything from 5 years to 25 years to 50 years to the life of a building or 100 years. Well, I went looking for actual data on corrosion in fire sprinkler system, and I came across this very interesting report. It was done by a company called BDS. BDS is an approval agency as well as an inspection and insurance agency based out of Europe. What they did is they actually inspect fire sprinkler systems across Europe, and what they did was they actually started looking at internal corrosion in those fire sprinkler systems. What they did was essentially develop different classifications of the internal corrosion in those systems. Class 1 is little or no corrosion damage, meaning nothing's wrong with the system. Class 2 means that there's enough corrosion going on in that system where pipe has to be replaced. And Class 3 is considerable amount of corrosion where the entire fire sprinkler system has to be replaced. So I have pictures as well of corrosion in fire sprinkler systems, things that we see in the United States. Here's an example of a wet system that I would consider a Class 1 corroded system. So essentially very little corrosion going on. As you can see in the next picture, as corrosion occurs more frequently, you start seeing larger corrosion deposits. This is something that would have to be replaced. If you opened up the sprinkler system and saw some corrosion going in, you need to replace that sprinkler pipe. And then you see things like this, where there's complete blockages of the fire sprinkler system, where no water would be able to flow. A system like this would have to be completely replaced. So to give you an example of how prevalent this is in the fire sprinkler market, the results of them looking at wet systems, what they actually found was after being installed for 25 years, about a third of those systems had enough corrosion going in. They actually had to replace pipe or replace the entire sprinkler system at a cost to the building owner. So here's some pictures of what dry systems look like with corrosion. This is the beginning of corrosion. I would consider this Class 1, something where it doesn't need to be replaced. As you see, as the corrosion progresses, you see more corrosion deposits, things that need to be replaced. Again, the sprinkler system, or the sprinkler piece of pipe will need to be replaced. And then you see things like this, where so much corrosion is going on in the inside of the sprinkler systems that the entire system should be replaced because this is prevalent throughout the piping array. So the results of dry systems were even worse. They couldn't even expect dry systems after 25 years. They actually had to shorten it to 12 and a half years because of so much corrosion going on. 73% of dry systems after being installed for 12 and a half years had to have corrosion replacement. So they had to replace sections of pipe or the entire piping system, again, at a cost to the building owner. So corrosion is a wide, significant problem that we're dealing with in the US, Europe, Brazil, everywhere. The main question I get is, what's causing the corrosion in the fire sprinkler system? Well, there's two different types. There's generalized corrosion, most people call rust, And then there's microbiologically influenced corrosion, also known as MIC. It's kind of a buzzword in the sprinkler industry. Generalized corrosion is basically what you have when you have water, iron, and oxygen. If you have all three of those in your sprinkler system, you're going to have corrosion happening. Microbiologically influenced corrosion is actually corrosion caused by bacteria in the fire sprinkler system. The bacteria actually creates corrosive conditions that lead to very fast failures in sprinkler systems. FM Global actually did a study on corrosion and wanted to determine what the main problem of corrosion was in fire sprinkler systems. What they found was 60% of sprinkler systems have corrosion failures due to just generalized corrosion, which is water, iron, and oxygen. 40% were actually related to the bacteria in the system. So the number one concern that we have with wet systems is trapped air in the sprinkler system. If you've ever opened up a sprinkler system and actually looked inside, you might actually notice on a wet system that there's lines. What the lines are essentially is where the water meets the air. This is called the corrosion air-water interface. It's a very corrosive area, and it can lead to a lot of corrosion problems and system replacements. So what does trapped air cause? It increases your generalized corrosion risk because there's more oxygen in the system. It also creates a better environment for bacteria to grow, so you can get more microbiologically influenced corrosion. And it can also cause unnecessary false flow alarms. In cases where there's enough trapped air in it, when the weather changes, when it gets hot or cool, it can actually expand and contract the air pockets inside the sprinkler system and cause the flow switch to activate. So why is trapped air a problem that we're starting to see more prevalent? One of the issues that we see is system design is changing. What you'll notice here is two examples of sprinkler systems. One is a gridded system, which ends up having a lot of trapped air in it, and the other is a system that had the inspector's test moved to the riser. What we have now is systems where we're not properly venting. If you don't properly vent a wet system, you have a significant amount of oxygen in there, which causes a significant amount of corrosion. One thing that we're working on at the NFPA level is writing a standard that incorporates venting sprinkler systems. This can be done by a vent, it can be done by a ball valve, it can be done by removing the sprinkler head. But removing essentially the oxygen in the system leads to longer life expectancies on those fire sprinkler systems. So dry systems. Dry systems are actually even worse, dry or pre-action. Dry and pre-action systems are worse because what they have attached to them is an air compressor. What an air compressor does is it injects in more oxygen, more water, and it causes those sprinkler systems to fail quite rapidly. And so what can you do to actually eliminate the corrosion potential in a dry system? Well, one thing that we found very effective is actually replacing the oxygen in that system with nitrogen. Nitrogen is an inert gas, which means it does not react with metal, which means it does not rust. So to prove out this concept, we've done a series of tests looking at the effectiveness of putting nitrogen into fire protection systems. Not for a suppression agent, but to slow down corrosion. So what I did was I put a series of sprinkler systems, small sprinkler systems, together, and what I did was I ran some with nitrogen and I ran some with compressed air. What you'll see here is a picture of a sprinkler system that was installed for 20 months. The orange color that you see is rust. That is the corrosion reaction happening. That is the pipe wall falling apart. I ran these exact same conditions, except for I replaced the compressor with nitrogen, and this was the result. Very little corrosion happening on the inside of the sprinkler system. If you compare them side by side, you see a significant advantage. So we got a series of data out of running this test, and what we wanted to look at was what was the effectiveness for the customer to use nitrogen over compressed air in a fire sprinkler system. What we found is, under a variety of different conditions, it reduced the corrosion rate quite significantly. What we saw was that you actually get a life expectancy increase in that fire protection system of about 5 times. So that means it's a system that would last 10 to 15 years before a contractor has to go in and replace pipe. you're looking at more of 50 to 75 years of operation, little maintenance on. We also found something very interesting. The old adage was using galvanized on dry and reaction systems would slow down corrosion. But what we've actually established through testing is that it doesn't really help. In fact, in some cases, using galvanized is worse. And that's actually made a change in the NFPA itself. What we see now is that the C factor for galvanized pipe and dry and reaction systems is now the same as a black steel system. So you're no longer getting hydraulic advantage by using galvanized. Nitrogen has been around for a long time. FM actually recommends its use in certain applications. What we see is during some of their property loss data sheets is that they can say you can actually use black steel with nitrogen. Because of what essentially nitrogen does is it takes away the corrosion potential. So how do you supply nitrogen to a fire protection system? That's the question. We used to use cylinders to essentially fill the sprinkler system up with nitrogen. The only issue with that is there's a lot of maintenance involved in that with replacing cylinders and changing them out, which has caused problems in the past. A new, more reliable source is actually the atmosphere. The atmosphere is 78% nitrogen, 21% oxygen. The trick is you have to remove that oxygen to cause a high percent of nitrogen. So how do you do it? Well, you can actually remove the oxygen from the air. One interesting development in fire sprinkler systems is the addition of nitrogen generators. What a nitrogen generator does is essentially creates nitrogen on site. This nitrogen provides the sprinkler system with the gas that it needs, but it is without oxygen. So how does it work? Well, there's a thing called the nitrogen membrane. What a nitrogen membrane is essentially a filter. And it filters out all of the oxygen in the air. There's a difference in the size of the molecules. Nitrogen is a larger molecule, meaning it takes longer to actually pass through this filter, while oxygen is much smaller and can pass through quite easily out the side. So to give you a diagram of what a nitrogen generator looks like, it's very simple and easy to explain, but what it is basically that air compressor that then goes through the filtering process. It starts with an air compressor that compresses the air. It is then put through some sort of drying mechanism to remove moisture, and then it runs through the nitrogen cabinet, which holds the nitrogen membrane. The nitrogen membrane separates out the oxygen, supplies it to a tank, which is then hooked up to your dryer reaction system. Whenever your dryer reaction system needs to get gas to stay up, let's say that you have a small leak, it pulls it from the tank. Once the tank loses pressure, the air compressor then fills it back up with nitrogen, going through the same process. So it's maintenance-free in the fact that you don't have to go out there and continuously change bottles or cylinders. So going over basically in summary, things you can do to protect your sprinkler systems, dry systems, is actually use nitrogen over compressed air, and use black steel over galvanized. Thank you.